Just say you are lost trying to find a gas station and saw someone passing by. What will you ask the person? Will you ask, "Can you tell me the distance to the station?" Or will you ask, "Can you tell me the direction to the station?" Obviously, the latter one, right? Only knowing how far is the gas station will not help you reach there. Of course, you do need to know the distance traveled, but you also need to know in which direction you have to travel. So what we see here is that in order to describe a location, direction plays an important role.
Quantities are completely described by their magnitude, whether it be mass, size, speed, distance, or even temperature. An example of that are scalar quantities. However, to completely describe a quantity, we also need to specify its direction along with its magnitude. Vector quantities are quantities that have both magnitude and direction. Vectors can be used to represent quantities like displacement, acceleration, and velocity. On the contrary, if two vectors are of the same direction, we need to add them. If two vectors are of the opposite direction, we need to subtract them. Meanwhile, resultant vectors are the sum of adding two or more vectors together. There are two methods in adding vectors, the graphical and analytical method. Under the graphical method are the parallelogram and polygon method, while in analytical method is the component method. Let us first talk about the parallelogram method. The parallelogram method is useful in adding two vectors, known as the tail-to-tail method. To graphically solve a parallelogram, you need a ruler or a protractor to find its resultant and direction. To solve analytically, we follow these formulas.
Polygon method. It is used to add more than two vectors, also known as the head-to-tail method. Given that 35 meters east, 37 meters south, and 60 meters west, find the resultant vector. Use the formula resultant equals square root of a squared plus b squared, and the answer will 53.24 meters. To find the direction, we use the formula tangent theta equals opposite over hypotenuse, and the answer will 61.99 degrees south of west. Vector component. The legs to the triangle are called component. The x represents the horizontal component, while the y represents the vertical component. Vector resolution is the process of breaking vectors into components. The formula for horizontal is ax equals a cosine theta, while the vertical is ay equals a sine theta. For example, 45 meters at 30 degrees north of east. Its x component is 45 cos 30 equals to 38.97, and its y component is 45 sine 30 equals 22.5. 30 meters upward, its x component is 0 and the y component is 30. 25 meters to the left, its x component is negative 25 and its y component is 0. The sum of all x component is 13.27 meters, and the sum of all y component is 52.5 meters. We will now solve for the resultant vector and its angle. To solve for the resultant, we use the Pythagorean theorem, and the resultant would 52.33 meters. To solve for the angle, we use the formula tangent theta equals ax over ay, and the answer would be 61.99 degrees east of north.